All right, we are in Chapter 6, Practice Problems with AP Stat in Unit 1. We're looking mainly at the normal model, and using the calculator to figure out our normal distributions is mainly what we're looking at here. And now we are looking at these in reverse. The highest 10%. Instead of us finding the percent that's there, working backwards in order to figure it out, basically. So here's how the calculator can work to solve this. It says it wants the highest 10%. You still draw the picture so you can see roughly the highest 10% and what they mean. But your calculator can figure out what the highest 10% is, but it always works from low to high. So when you plug this in, even though I want the highest 10%, this number, whatever it is going to be the same number if it was the lowest 90 or the highest 10. So I need you to be aware of that. So all I'm implying by this statement is when you plug it in, I have to plug in 90 because, again, it's the same number both ways that I'm looking for. Whether I'm asking you for what's the cutoff of the highest 90 or the highest 10 or the lowest 90. So when you plug it in, you got to use this. So to use your calculator, you go to second vars, and in second vars, you scroll down to find inverse norm. So once you find inverse norm, since I want the from low to high, I actually want 90%. Plug in 0.90, and when you do, you will get the z-score of roughly 1.282. Now, over here, since I have the z-score, and I know the mean, and I know the standard deviation, I can multiply by 84, then I can add 1152 in order to get my answer, is basically how this would work. All right? So, just things to think about when you're doing. However, you can also do this all in one step without even doing z-scores at all to figure out the exact number and what the weights are by putting in the perspective. What you're going to do is you're going to press second vars to go to inverse norm. Still the same number, so you're going to do 90%. So you're going to type in 0.90, comma, but the standard deviation and the mean that we're using, we're going to use the actual numbers. And the mean is 1152, so it's 0.90, comma, 1152, comma, 84, and you will get that number right away without even doing any of that z-score math with your calculator. So approximately the highest 90% of steer weights are expected to be above 1,259.7 pounds. Now they want the lowest 20. So when we're doing this with the calculator, since I want the lowest 20, and this is why, again, you draw the picture, the lowest 20 is already here. It's already listed. We're already good. So what I mean is, now when you do it, you would do inverse norm. So you press second vars. Inverse norm, so I plug in 0.2 because it's already from low to high, comma, I would just do 1152, comma, 84, and I get this 1081.3 right away. Or I could have found the z-score by simply just doing inverse norm 0.2. And when you don't plug anything in, they're assuming you're talking about a normal model. That's why you can just do inverse norm 0.2, but technically you would type in inverse norm 0.2, comma 0, comma 1 to put it in its normal form. But the calculator assumes the normal form. But there is the lowest 20%, so according to the normal model, the lowest 20% of weights of steers are expected to be below approximately 1081.3. And then the middle 40%. Now, here's where it gets a little fuzzy. Okay, so in order to do this, if I want the middle 40% to try to figure out what these are in between, okay, I need to figure out the low and then the high in order to make this work. Do you follow me? Because remember, I told you we're only going from the low and then what's the other half? But because it wants the middle 40%, I need to try to calculate what those z-scores or pounds are at each mark, if that makes sense. So how can I go about when they want me to find the middle of something, the middle 40%, right? So here's how it works. All right, so here's what I would do. Since they want the middle, right, the middle 40%, this is literally 50%, right? So if this is literally 50%, all right, and that's cutting everything in half, and they want the exact middle, that means I'd have 20% on this side and 20% on that, if it's literally in the middle, because they want the middle 50%. So if this is 20% lower then technically what they're saying is this is the 30% mark, 30% right here. And then if this is 20% higher, that's a 70% mark. So what I'm implying here is this would be the low 30 to figure out what this mark is, and this would be the low 70 to figure out what that mark is. So if you do inverse norm 0.3, comma 0, comma 1 to make it in normal form, I would get this. And if I did inverse norm 0.7 for 70%, and I decided to do 0.7, comma 0, comma 1, I would get a positive one here. So this would be actually a positive 0.524 to find out what they are on each side. But you can do this all in one step without figuring out what the z-scores are, because technically what you can do is, if you went to second vars and then you typed in inverse norm, right, and we typed in the 0.3, comma, and 1152, comma, and 84 for our standard deviation, I get the 1107.9, which is basically 1108. And if I do it again, but now I do second vars and I do inverse norm for the percents 0.7, because it's 0.7 from here up, comma, and now when I do that, it's 1152, comma, because that was the mean standard deviation of 84. I would get the 1196. So there would be the pounds and the difference between the two. So the middle 40% of all steers would be between 1108 and 1196. So dealing with the IQs again, we still have the same cutoff. It's normal. So that's telling me that is the mean. That's the standard deviation. So the highest 5%, I want the lowest 30%, and I want the middle 80%. So again, drawing the pictures to be helpful. If I want, and I'll go through this a little faster now, but if I wanted the highest 5%, it's the same as the low 95. So you would go to inverse norm, you would plug in 0.95, I would do comma 100, comma 16 to get to this right away. All right, or you could obviously just do inverse norm 0.95. And then it would spit out the z-score right away because you would be using the normal model of 0, comma 1. To find the low 30%, right, for us to find the low 30% when doing this, now that's just from inverse norm 0.3, but now comma 100, comma 16 for the standard deviation, I would get 91.6 right away. Again, if they wanted the z-score, I would just do 0.3, inverse norm 0.3, and I'd get the answer right away, or inverse norm 0.3, comma 0, comma 1, whichever one works, but then I would get my z-score for that. So according to the normal model, the lowest 30% of IQ scores are expected to be below 91.6. The middle 80%, right? Again, if that's literally the middle, that would be 40 and 40. So we can do this quick and right away. So middle 40. If this was 50 and this is 40 that way, this is actually 10%. And if that is 50 plus 40, that'd be 90. So I want between 10% and 90% is what I'm looking for. So I would do, to do this one correctly, I would do second vars, I would get inverse norm 10% for this low number, comma 100, comma 16, and that gives me my 79.5 right in the button. And if I wanted this one, knowing that that's 90, I would do second vars, I'd find inverse norm, that'd be 0.9, comma, and then I'd want 100, comma 16. And that is 120.5. And that would get me to those right away. Or I could do inverse norm 0.1, comma 0, comma 1 to make it in standard normal form. And I could do 0.9, inverse norm 0.9, comma 0, comma 1 for the standard form to find the z-scores as well. So either way you slice it, the picture does help. It helps me anyway to find what percentages I'm looking at from low to high. So according to the normal model, the middle 80% of IQ scores are expected to be between 79.5 and 120.5. Over here, we have considered the Angus weight models from 1152 one last time here. what weight represents the 40th percentile. So now I'm looking at these problems in terms of percentiles instead, which is not that hard. What weight represents the 99th percentile, and what's the interquartile range of the weights of these. So, point is this. When you're looking at these, I'll just give it a start, and then we might have to finish in another video here. But if I want the 40th percentile, right, if that's what I'm looking for, the 40th percentile, you got to remember what that means. That means you are better than 40 others. So that's telling you, percentile is basically telling you the low. So when plugging this in, that would be the low. And then the 99th percentile, again, that would mean that I'm better than 99% of them, which means that number is me and everything is lower than that. And then the interquartile range, remember, the interquartile range is between 25% and 75%. So by them saying that, I need to find what that 25% and below is, the 75% and below is, and then I can figure out what those numbers are and find the range between them. So when I come back, I will kind of go over that, and we'll figure out those answers.